Good morning students and welcome back to your physics class, and today we will be dealing with a new topic, that is sound. You must have studied in detail about sound, how it is produced and how it travels from one place to another. But today in class 10 we will be dealing with some characteristics of the sound. So as you have studied in smaller classes, sound is a form of energy which produces in us the sensation of hearing. Sound is a form of energy which produces in us the sensation of hearing. We are able to hear things because of vibrations produced by objects. I am talking here, my throat, my larynx or voice box is vibrating, and that produces the sound. When you play a musical instrument like guitar, the string vibrates and it produces sound. When I clap my hands, the air is vibrating which produces the sound. So sound is produced by vibrating objects. These vibrations travel through material medium. Sound waves need material medium for its propagation because sound waves are mechanical waves and they need material medium. That means sound cannot travel through vacuum. Sound needs material medium. It can be gases, liquids or solids. Sound can travel through air, sound can travel through water, and sound can even travel through iron. So more dense the medium is, faster the sound can travel. That means sound can travel faster through iron than it can travel through water. Sound travels at a lesser speed in air when compared to that of water. The speed of sound in air is nearly 332 meter per second at 0 degrees Celsius. So at this temperature, sound travels at a speed of 332 meter per second through air. So when temperature increases, the speed of sound also increases. For example, at 15 degrees Celsius, the speed of sound may reach up to 340 meter per second. Sound waves travel as longitudinal waves with compressions and rarefactions, or they travel as pressure disturbances. Sound waves can be reflected. Like light rays, sound can be reflected, and sound waves obeys the laws of reflection also. So as you can see in this picture, the sound produced, the tick tick sound of the clock is reflecting from that board and it can be heard through our ears when you keep it at that angle. A small hollow pipe is kept so that the sound from this can travel and it can be heard in our ears. It obeys the laws of reflection, that is, the incident sound wave, the reflected sound wave and the normal all lie on the same plane. The angle of incidence will be equal to angle of reflection. These laws are obeyed by sound waves. But sound does not need a mirror for reflection. It just needs a large, hard surface for proper reflection. Based on this reflection of sound, we have a special property that is known as echo. Echo is usually heard by us when we are standing near to a cliff or in a high-rise place. Echo is simply the reflection or repetition of the original sound after reflecting from a rigid surface. It is the repetition of the original sound. The original sound will be repeated after reflecting from a surface. For example, if a person is standing at point A and there is an obstacle at point B, if a sound produced by this person can travel, hit the surface and come back to the person, and you will hear the reflected sound after a short period of time, maybe some 0.5 seconds or after 1 or 2 seconds, then that second sound is called echo. Then how to calculate the time period of an echo, or how to calculate the time of an echo? Suppose this person is standing at a distance d from the obstacle. What we do here is, this sound wave is actually traveling through the distance d, and it is traveling back again through another distance d. So the total distance traveled by sound is 2d, and when you divide the distance by velocity of sound, you will get the time of echo. So how much time it takes between the production of original sound and the reflected repeated sound. That time can be calculated by using this formula, 2 into distance by velocity. And also we can calculate the distance, minimum distance required for minimum distance required for creating an echo or an echo to be heard. That can be calculated because we have a short time gap within which our brain can detect two distinct sounds, that is 1 by 10 of a second or 0.1 second. Our brain needs a gap of 0.1 seconds between two sounds to separately distinguish them. Otherwise, the first sound will merge with the second sound and we will hear it only as a single elongated sound wave. So, to distinguish between two sound waves, we need a gap of 0.1 second. So, what we do is, we give the time as 0.1 second and we leave the distance as it is 2d, and we know the velocity of sound in air. Earlier we said that velocity of sound in air at 15 degrees Celsius is 340 meter per second. So I write here 340 meter per second. So I put the 340 here and 2 below here, and we get distance is equal to 340 into 0.1 divided by 2, and when you calculate it, you will get the distance to be 17 meters. So this is the minimum distance required for hearing an echo. That means the producer of the sound and the obstacle should be at a distance of 17 meters, so that the sound can travel from here to here 17 meters, travel back 17 meters, and then you will hear the echo after 0.1 seconds. It's because of persistence of hearing of our ears. It is because of the persistence of hearing. Our hearing capacity of a sound will persist for 0.1 seconds after it is heard. We have earlier studied about persistence of vision in our eyes. Our eyes can retain a vision received by it for a time of 1 by 24 seconds. That's why we make 24 frame per second film rolls and all. Here the persistence of hearing is 0.1 seconds. Now next we will discuss about conditions for hearing a distinct echo. To hear a distinct echo, we have 4 conditions for it. The first one is the time. The minimum time gap for the original sound and the echo must be 0.1 seconds, then only we can hear a distinct echo. Second one is the minimum distance. The minimum distance between the producer of the sound or the source of sound and the obstacle at which the sound is reflected should be 17 meters. Third point is that the obstacle should be large enough, maybe a cliff or hill, a mountain, or it should be a large building or a large wall. So anything of a large size is needed for the reflection of the sound. And the fourth point is that the sound should be of sufficient intensity for it to travel till the obstacle, strike it and get reflected back. If the intensity of the sound is less, then it will not go and come back. It will dissipate its energy and the sound will not reach us. So sound should be of a high intensity, a loud shout or a sharp clap or the sound of a gun or a drum. Something of a high intensity should be produced so that it can travel the long distance and come back to us. There are chances of multiple echoes. Multiple echoes are heard when there are many hills and sound will strike one hill, reflected to another hill, then reflected back to us. This first sound also reflected, so we can hear multiple echoes. This happens when many hills are there or two large buildings are at a distance and we are shouting at that building, sound is reflecting back, this sound is again reflected to that side. So 2 or 3 times the single sound is reflected, and that is called multiple echoes. And the best example for multiple echoes is the rolling of thunder. So usually when you hear a thunder, it rolls out. Thunder will elongate for a long time. It will be reflecting at different surfaces. Okay, that's with echoes. And now we have to calculate maybe the time period or velocity of air, or we have to calculate the distance between two structures. So that can be done using the echo method. Now we will do a problem and we will familiarize how to do numericals related to echoes. Okay, so here we have a question. A boy whistled for a short time near a cliff and heard the echo after 3 seconds. Find the distance of the cliff from the boy, and the speed of sound is given to be 344 meter per second. So now we can do write the formula. Before writing the formula, we have to take and write the values. 3 seconds, that is time. Time t is equal to 3 seconds, and then we have speed of sound or velocity of sound. Speed of sound v is equal to 344 meter per second, and we have to calculate the distance of boy from the cliff. So according to formula of speed, we have velocity is equal to distance by time. When solving the problems of echo, we have to take the distance as 2d. And now we have to substitute the values. So instead of v, we can write 344, which is equal to 2d by time is equal to 3 seconds. Okay, now as you have written the values, the formula and substituted, you will get 1 mark up to here. Now you have to solve and find the answer. And here 2d is equal to 3 into 344, distance is equal to 3 into 344 divided by 2, which is equal to meter. Now as you find the answer, you will get 1 more mark. So this will most probably be a 2-mark question. So you will get questions related to echo in this session. So find the answer. This echo is very useful in various fields. Even animals use echo methods. You must have heard about bats. They have eyes, but they have a special feature. They can produce high frequency sound from their mouth, and this sound will strike some object, maybe an insect in the flight, and it will get reflected from that object, and their ears can capture this high frequency sound, and they can detect in which direction the fly or insect is flying and at what speed it is traveling, and the bats can easily catch them. So bats use echo method for finding its prey. So echolocation is used by bats, and they use ultrasonic waves. Ultrasonic wave is something which you have studied in smaller classes. A sound wave can be infrasonic, sonic or ultrasonic. So it is categorized based on the frequency of the wave. The waves which have frequency between 0 Hz or 1 Hz to 20 Hz is categorized as infrasonic, and the sounds which are between 20 Hz to 20,000 Hz is known as sonic or audible range, and the sound which is above 20,000 Hz, sounds having frequency above 20,000 Hz is known as ultrasonic waves. Human beings can hear between 20 Hz and 20,000 Hz. So bats produce some sounds which is above 20,000 hertz, and that sound is used for echolocation of insects or its prey. Not only bats, even dolphins. Dolphins also communicate underwater over long distances using echolocation. They can detect food, or they can communicate, or they can even scan the surroundings using echolocation method. Fishermen. Fishermen have a device which is actually a device which produces an ultrasonic pulse which travels, and when it hits or when it strikes a shoal of fish, that sound wave will travel back and it will be received by the detector or receiver, and the fisherman knows that in this area of the sea there is fish available, and they will go there and catch those fish. And fishermen also use echolocation or echo method for finding where they can find fish. They are used mostly by trawlers who use boats and large nets. They have a device for producing and detecting ultrasonic waves. The best example or application of echo is found in sonar. Sonar stands for sound navigation and ranging. Sonar stands for sound navigation and ranging. Sound navigation and ranging is an echolocation method used by scientists to study the things which are under the water. They have a producer of ultrasonic waves. These ultrasonic sources produce a pulse which travels to the seabed. When it strikes an object, that sound wave will be reflected back. It will be detected by a detector, and that wave will be converted into electromagnetic pulses and maybe even converted into pictures. So we can photograph the floor of sea, or we can photograph the seabed using echo method or sonar method. The sonar is used in various fields. It is used by submarines to detect where the enemy submarine is or where the other ships are. They are detected to scan the seabed to find what all articles or objects are there, and if they have to study about any ship wreckage or something like that, they can use the sonar. And sonar is also used by large ships for detecting the depth of the seabed. If there is no enough depth, the ship will not move forward. So there are many applications of sonar. Even sonar and echo method finds its use in medical field. There is echocardiography. The sound waves can travel through our muscles, and when it hits our heart muscles, which are thicker, the sound waves can detect the movement of the heart, and they can measure or they can picturize how heart is functioning. It is also used to view other internal organs. Even the growth of a baby can be examined using some ultrasonic echo methods. So in the medical field also echo is used. In sonar also echo is used, and it is used by fishermen, and in the world of animals, bats and dolphins use echo method for various activities. Now we see that most of them are using ultrasonic waves for echolocation. The ultrasonic waves have high frequency. High frequency is associated with high energy. So if you are using normal sound waves, what happens is the sound, when it travels through air or water, its intensity will be lost very easily. Ultrasonic sound waves, on the other hand, is having high amount of energy, so that it can travel through the medium and it can also travel back after reflection. That is why we use ultrasonic waves. And also ultrasonic waves do not interfere with other sounds produced in the medium. For example, if we are using sonar in a ship and the sonar device is usually attached to the bottom of the ship as it is shown in this picture, and when the sound is produced by that device, if it is in the audible range, what happens is the sound can interfere with the sound produced by the machine or the engine of the ship. To avoid that, we make use of ultrasonic waves in a sonar device for detecting the objects which are under the sea. Okay students, today we have learned what is sound. The sound can be reflected, and the repetition of the sound after reflection is called echo, and we learned about the conditions so that we can hear a distinct echo. Then we learned how to calculate the velocity of sound or the time using echo method, and we learned about some applications of echo method. Okay, in the next class we will be dealing with free vibrations, damped vibrations, and resonance, then loudness, pitch, and quality of sound. Okay, now what you have to do is read the textbook and answer the questions at the back and learn this topic very well. Thank you all.